Hello everyone, this is Ninja. This is episode 6 of Kerbal Space Program. I'm going to try and make this a quick episode today because we're going to do kind of the same thing we did last episode, except this time we've got a little more technology on our side and we should be able to get a lot of more science out of the mission, which is just getting close enough to the moon where we're in its gravitational pull for a little bit and do some science, and we're going to transmit it back. We're going to transmit as much as we can and then get maybe a little bit more and then try and land back on Kerbal. But if we don't land, we can still get quite a bit of science out of the mission. So let's get started. And I already have the rocket built, and I've tried it out, so I know this thing will definitely do the job. I'll show you some of the changes to this thing. Let's load it. It's the Mark II. I'm gonna have to keep a pretty simple naming convention. Okay, so the differences with this one is we got a different cockpit. Not really sure what the differences are with this thing. I know it's slightly heavier. Other than that, I'm not quite sure. I know the guy inside has a better view, so it's nicer for him. Let's see, we've got 16 batteries on here, so we got quite a bit more power to transmit the data back. And since this thing has a point on the end of it, we need a different chute. So I've got the radial mounted parachutes, so this thing will land softly on the bottom for sure, I think. I think. If we lose this stage, we only need one, but if we want to land both, I've got another parachute just in case. Probably aren't going to need that though, actually. Now that I think about it, yeah, let's just get rid of this. This is a lander just in case we get a little too close to the moon. We can just land there instead. And just transmit as much scientific data back to Kerbal as we can. But I'm trying to just do another flyby. And I still have the same setup here with the 7 solid fuel rockets. Seems to actually work out a lot better than putting liquid fuel rocket in between this and detaching, because that's how I used to do it, and it never seemed to really get the same positive results that I get with this. So, all right, let's get this thing launched. And yeah, I still kept the wings down here to keep it steady. And you know what? I actually have one other thing I have here is one of these inline reaction wheels to keep this thing stable, and it's a lot easier to control it once it's in, once I'm in the second stage of this. It's very much easier to keep control of it. So okay, let's go to the launch pad. Okay, not gonna waste too much time here. Let's just get this launched. And you gotta throttle up for the next stage. Okay, let's see how we're doing here. Doing okay. 529 per second. Let's start leaning a little bit. And I think I'm gonna get up to 85 and then I'll cut the engine. Maybe 90. Yeah, somewhere in there. Okay. And once we get about right there, we're gonna get it a 90-degree angle and yeah, full throttle. Get as much orbit out of this stage as we can. Let's see how much fuel we have left. About 2/3. Okay, once this reaches about the 45, that's when I know to put the throttle at full. That keeps the periapsis in front of us. Or the apoapsis, I should say. Okay, and once this fuel gets down low enough, we'll have to switch back to the staging view. Okay, I'm gonna increase my angle upward a little bit just to keep that in front of me. Because I know once you get beyond this point, it seems harder to really increase your orbit. Okay, that's the end of that. I said stage only, but for some reason it doesn't work quite right. Okay. And because of that, we're gonna have to angle up a little more. Or maybe not, I don't know. I don't know if I'm really, doing this right or not. Okay, we're almost there. Almost have an orbit. There it is. And then once this comes around about halfway, that's when you know. Oh, okay. Went a little past it. That always seems to happen though. Okay, now where is the moon? There we go. I think I forgot to cancel that last mission. Okay, I'm gonna actually go get rid of that first. Yeah, this one I ran out of fuel. This was kind of more just testing to see what I was capable of doing in this, see if I could maybe do a landing. I don't think we're there quite yet. Need a little more, little better engines to get us all the way down to the surface, because you got to bleed off a lot of the speed that you, that you need to build up to get there. Oops, not here. Wrong place. Okay, let's get back to this. Okay, back to business. There it is. Let's set it as target. Looks like I'm gonna have to maybe go around once more. Let's see if we add a marker or add a maneuver here. Oops, screwed that one up. Let's get rid of that. Okay, now let's see. I don't really want to catch it on the way back though, because then we're going to have a lot of speed building up to it. You want the apoapsis to be somewhat close to where your moon encounter is going to be. Oops. Oh, I never noticed that before. Okay. Target position at closest approach. That's very useful. So let's work with that. Alright. This I think is ideal, actually. Well, let's see how long of a burn this is. NA. That's not good. Why NA? Does it mean we just don't have enough fuel? I don't know. Once we get the engine started, I think it'll stop saying NA. Okay, getting pretty close. 14 seconds. Now, I want to do it from this view, so I can get precise when I start getting close. Okay. One minute. We definitely have enough fuel for that. And it's going faster than the estimate. Go down to half throttle. Let's go down to just a pinch. Okay, that's a little different, probably because I slowed down near the end. It's still a little more precise though, or at least it seems that way. This is good though, because we're coming close, just close enough to where we can kind of slow down enough to, you know, so we don't have a ton of speed going into the moon. I don't know, we'll see when we get there though, how it ends up being. So let's fast forward. Ooh, a little too fast. Maybe not. Okay, let's slow down right here. Alright. There we go. Let's slow down all the way. So we're moving this way. 322 meters per second. Let's see if we add a maneuver here and then try and bleed off some speed. Yeah, that'll get us into an orbit. Pretty wide orbit though. Well, you know what? I think we should save that fuel so we can just land back on the planet. Bring the science back, because otherwise we're not going to. There's not enough fuel to land and get off and make it back. That's just not going to happen. Maybe if we had more powerful engine or something, but either that or if we had another stage right here with docking or something like that, but not even close. Okay, so let's just get rid of this maneuver actually, and let's do some science. Okay, 75. We can only get 27 or 20% of this if we transmit those, and that's a lot of space. So I think we should just save this one. We can transmit back crew reports though. 5.6 science out of that. And we can do EVA. Oop. EVA report. 3.4. Not so good. Hopefully we can get on here easily. I'm pressing F, but it doesn't seem to really matter. Yeah. It's going to be kind of difficult getting back on board here. Okay. Finally we got on. I just was holding down F as long as I could. It seems to work. Okay, so let's do... Oh, I forgot the goo. Can't send any space goo back. That's a bit of a fail, but that's okay. Let's review this. Let's do another crew report. Save. Review our data. Transmit this. And transmit that too. Although nothing happened. Okay. Okay, I think we've pretty much used up our crew report. You know, let's try transmitting this. I mean, I know we're losing quite a bit of it, but just in case we don't make it back, we still get quite a bit of science out of this. Okay, 64 again, so that's pretty good. So we get a little extra out of that because it's 64 plus the 15. Okay, so let's just head back to the planet by fast forwarding. Okay, we're already near. Oh no, we're not. Let's see. Oh, slow down time again. I need to bring this down a bit. So let's turn so we're facing retrograde. There we go, and just throttle up just a little bit, just enough to bring this down slowly. We'll try and bring it to 30. Now maybe 25,000 actually seems a little better, because 30 was, it kind of skipped off the atmosphere before. I had to make another trip around, as you might remember from last episode. Okay, 22. That's good. Okay, so we're going really fast. We need to bleed off a lot of the speed. The atmosphere should really take care of all of that for us. 30,000 last time wasn't quite low enough yet for the last re-entry here. Still have a bit of fuel too. I could actually burn this off. And let's get rid of that stage. Go ahead and try and face the right way. Okay, this is most definitely going to bring us to a landing here. And we're now down to 700 meters per second. Let's deploy the chute. Need to try and kind of make sure I'm facing the right way though. Okay, that should be good. I hope we don't hit the ground at an angle though. Yeah, because this is a lot heavier than this side, so it might have been better to put another one near the nose or something like that. I think it'll be okay though. Can maybe actually use the SAS when we're closer to the ground to level it out. Yeah, it seems to work. Good. Whoa. Chute deployed. I almost thought I was touching the ground there for a second. And there we go, safe on the ground. Let's do an EVA. Take a soil sample from this area. 0.6, okay. I guess we've bled that one dry. 0.1, yeah, there's no reason to even keep that. Alright, so let's recover this and see how much science we get out of that. 95, that's very good. That'll be enough to buy something else here. I think all of these cost 90. So we could get solar panels. Problem with this is, even if we land on the moon and transmit everything back, we'd be losing a percentage of it. Still might be better to spend it on rocketry so we can get there a little easier. Not really a lot of great stuff out of these stages here, besides this, these panels. But right now, power is not really an issue. We've got enough batteries with us. So this is what I'm gonna need to go with. So that leaves us with 50. Struts would be good for making bigger spacecraft. You want to use these struts to kind of stabilize everything. And these are good for launch. Keep your stuff from tipping over in case it's really heavy or really tall. Radial decoupler. Okay, so we might as well get this since we can afford it now, and this stuff might be good for building a bigger rocket. That way our last stage can have a lot more fuel to get to the moon. But that's it for this episode. Thanks for watching, everyone. I'll see you next time.